Today we're taking our first step into the big wide world of pH and pOH and what that actually means. And so these two guys you want to have written down, so please stop the recording and write them down. Okay, with this screen written down, I'd like you to open up your textbook to page 611 and do what I have done here. Get a piece of paper to cover up so that you just see this much of that two-way arrow on that page, and then another piece of paper to get rid of these concentrations so that we can concentrate on just the pH. And I want to give you a feel for this. Now ask yourself in your own mind, what is a pH of 7? And here's a class. What do we have for a pH of 7? Neutral. Good. Okay, as the pH goes down, what happens? Does it become more acidic or more basic? More acidic, yeah, okay. And going up, we become more basic. Okay. Now, what we're doing today is we're going to try to figure out what this stuff is all about in regards to pH and pOH. Basically, the hydrogen ion concentration of 1 tells you that the pH is 0. Now, how do you know that? Because of this. These guys up here. We got to make sure we have these guys as well. So, what are these guys? The minus log of the hydrogen ion concentration is equal to the pH, and the minus log of the hydroxide ion concentration is the pOH. And as we saw in that little graphic, a pH less than 7 means it's acidic. And let's do that side by side with that graphic. Here we go. pH less than 7 means acidic, so we go from here down, we've got acidic. A pH greater than 7 means that it's basic. Now, if you look at that graphic and bring your paper down so you can see the pOH, okay, the pOH is going to be exactly the opposite. It starts at 14, which is equivalent to 0 pH, and it goes down to 0, which is equivalent to 14 pH. 7 is in the middle in both. Something else that is very interesting. If we look here, where did I go? Yeah. Minus log of the hydrogen ion concentration. Let's use this right-hand screen now to talk to, and I'm going to go down to the bottom of that. Minus log of the hydrogen ion concentration is going to be what? What does that mean? What's the definition? This is equal to what? Oh, this is pH, folks. Okay, that is your pH. So, now let's look at this. The hydrogen ion concentration is 1. The minus log of 10 to the 0 is 1. Or 10 to the 0 is 1. So the pH is 1. Or the pH is 0, I'm sorry. pH is 0 for a value of 1. As soon as we get into powers of 10, 10 to the minus 1 is going to be, take that minus 1 and change it to the opposite sign. See? That's what these guys do. Right down here. So the minus log of the hydrogen ion concentration is equal to the pH. Whatever the power of 10 is, it's going to be the pH if we change the sign. 10 to the minus 4. What is the pH? 4. Why? Because the hydrogen ion concentration being here we go. This guy is 10 to the minus 4. The minus 4 becomes the pH after we change the sign. That's why we have the minus log. The whole point of pHs was to get rid of the minuses and the powers of 10. And it's really nice to be able to see a pH of 4 than to look at a power of 10. Don't you think? Isn't that nicer? So, take this number, change the sign, and you have your pH. If this is the hydrogen ion concentration, what if it's the hydroxide ion concentration? If the hydroxide ion concentration is 10 to the minus 4, what's the minus log of 10 to the minus 4? 4. Yeah. John? Oh, okay. You were showing me 4. All right. Let's go on and do something else that's kind of fun. We just said that the pH plus the pOH is 14. Now, I want you to add these numbers up. 0 and 14. What is it? Oh, 6 and 8. Oh, 10. 14. 10 and 4. 12 and 2. You see, these verticals, you always have the two guys added up, or the two guys will add up to 14. And that exponent becomes the pH if we're on this line, or when we're on this line, oh goodness, what's that relationship? This times this is 10 to the minus, oh yeah, 10 to the minus 14. Oh, 10 to the minus 7 times 10 to the minus 7, 10 to the minus 14. 10 to the minus 5 times 10 to the minus 9, 10 to the minus 14. Okay? So these two guys, this little graphic shows you beautifully the relationship of the pH and the pOH. And you see down at the bottom there, and let's concentrate just, ooh, I can't do that. Okay, that's not going to work. But at any rate, the increasing acidity to the left, increasing basicity, however you say it, to the right. And in the middle, we have the neutral. So the part that you are most familiar with is most likely this line right here. And this graphic allows you to get a handle on how all this other stuff plays into what you already know. Okay? In teaching, this is called scaffolding. This you know. The other stuff, you're not real solid on yet. So that's what I'm hoping to achieve in this video. Now, I've given you 6 problems for homework tonight. Each of them has 3 parts. And this is how it's going to work. And you might want to write this down because it will help you tremendously in doing your homework tonight. Here's my directions as written on the homework page. You need to write down everything that you see above my shade. So the critical information here you will need, and the critical information here I think you already copied down on your whiteboards, but those of you watching at home, you'll need to copy this down so you can follow. All right, so turn off the recording and copy what you need. So here's our first example. You're going to find these things go fast because you don't even need a calculator for this. The math is really, really simple. So here we go. The first problem each time is to, if we're given the pOH as we are in this one, we're going to take the minus log of the hydroxide ion. So what you're going to do, so on your homework paper, you need to show you're looking for pOH. You need to show that the definition of pOH is minus log of the hydroxide ion concentration. Every time you write this, you'll understand this better. Next, you've got the minus log of 10 to the minus 4 because that's what was given. And that was the hydroxide ion concentration, as we see here. Okay? When you plug that in, the minus 4 is the log of 10 to the minus 4. That's the definition of a logarithm, the exponent of a power of 10. When we put the minus out front of the log, what that does is it changes this negative to a positive. So minus 4 becomes a becomes a plus. And so this guy becomes an answer of 4. And I want a box around that guy. So your homework is clear. Anthony, wake up. Oh, good. You need to be looking up here then. pH plus pOH is 14. That's what you do to start the second part of your homework problem. So, hydrogen ion is equal to 14 minus 4. Or the pH, I'm sorry. The pH is equal to 14 minus 4. Why? Because we just found the pOH. So we take this number directly down here, subtract from 14, and as we learned at the beginning of this video, those two guys adding up to 14 is essential. So 4 plus 10 is going to be 14. 4 and 10, 14. Okay? And that's how you check to be sure that you did it right. Next, this pH is actually greater than 7. So we're going to use this guy as our reason. pH greater than 7, solution is basic. And then you put a box around this, and you know that this is a basic solution as your answer. Okay, one more problem, and then I'm going to let you go to actually doing some problems on your own that you would have in your homework. And you can start getting this down immediately. Okay, so here we go. Hydrogen ion concentration is what we're given this time. Because we're given hydrogen ion concentration, we have 1 times 10 to the minus 6 as the given. And tomorrow we're going to learn what to do if this isn't 1. It's going to be simple, just as simple as this almost. Almost as simple, yeah. So, pH minus log of the hydrogen ion concentration, that's the first thing you write. Second thing you write is you're plugging in the 10 to the minus 6 to this, okay? And 10 to the minus 6 becomes a pH of 6. Second part of the problem, we simply know that pH plus pOH is 14. So to get the pOH, we just subtract this 6 from 14, and that gives us the 8. And that's called the pOH. And the last thing we have is the pH is less than 7, means the solution is basic. That is our reason for our answer of the solution is basic. Okay, question? pH of the solution is less than 7. pH is 6. Okay, the pOH is 8. Don't feel bad. Yeah, we got a lot of stuff going on in your heads right now, and a lot of it is brand new. So, yeah, pH is less than 7, and we always look for the pH. I'm asking you to find the pOH if you're given the pH, if you're given the hydrogen ion concentration, and if you're given the hydroxide ion concentration like the first problem, I'm asking you to find the pH. Now, you don't have to have the hydroxide ion concentration to have the solution, but here you got a pH to start with. You don't have to have the hydroxide ion concentration here, but I want you to calculate it anyway. That's why you do not want to follow the directions in the textbook, because then your homework will be incomplete. Okay? Any questions? Cool. That's the end of our video. I hope you at home have learned something and can do your homework properly. I'm adding a short trailer here. When you check your answers, your pH and pOH have to add up to 14. that's a double check to know that you did them right. And so if we look at the first problem, let's get the pointer up here. Okay, 4 plus 10, 14. So you know that you've done it properly. Okay, that's it. Bye-bye.